Hello. So let's learn about two-particle system, which is given in your first unit of mechanics. Any object, any body is made up of numerous parts. We all know this. Now let's take this case of this eraser. This eraser is made up of number of parts, tiny, 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 tiny parts. If you're asked to chop this eraser, you can make it into small, small parts. All of them put together makes this eraser. So any object is made up of numerous parts, which in this derivation we are going to call as particles. Any object is made up of numerous particles. So what happens when all these particles interact with each other, and where is the center of any object? So for example, if I take this object, it's only in the center I can balance this object. Only in the center I can balance this object. That is because all these particles have a center. So what the center is, how it is going to act, and all that we'll be seeing in the forthcoming classes. But taking the fact that any body is made up of many particles, we are now going to consider only two particles so that we can generalize the derivation later on for many particles. So we are now going to consider a body which is made up of just two particles, and these two particles are actually exerting a force on each other. So let us go into the derivation. Right. So what we are going to see today is the derivation, which is called a two-particle system. Okay. It is a two-particle system. So let us say I have a rod with me or a scale with me like this. So which is actually extending only along the x-axis. So this is only extending only along the x-axis figure. So I am actually considering that this rod is made up of only two particles. Let us say x1, at a distance x1, I have the first particle which has some mass m1, and at a distance x2, I have my second particle and this has some mass m2. So I have two different particles. Now the force on x1, let me write the force on x1. And you know from Newton's second law of motion, force is equal to mass into acceleration. So I am taking here for F1, which is the force on x1 equal to m1 into a1. Okay, m1 into a1, and you all know a is the acceleration. Or I can write this as m1 a1 is equal to f12 plus f1e. Why am I writing this? I am splitting the force component into two different components. F12, which is indicating the force on 1 due to 2, plus F1e. E is all the external forces which is acting on the particle. You would have learned about a free body diagram in your school. And you know, when there is an object, there are various external forces, let us say like gravitational force acting on the object. So those comprise of the external force. So m1a1 is equal to f12 plus f1e. Similarly, for particle 2, I can write m2a2 is equal to f21 plus f2 of e. Am I right? So similarly, if this is for particle 1, I will say this is for particle 2. So the total force acting on the body can be given as m1a1 plus m2a2 equal to f12 plus f1e plus f21 plus f2e. Am I right? So let me rewrite this. So this will be equal to m1a1 plus m2a2 is equal to f12 plus f21 plus f1e plus f2e, right? Now let us take only these two forces into consideration. So these are the two particles. So this exerts a force on this, right? Similarly, this also exerts a force on this. And according to Newton's third law of motion, the force exerted by this particle on this is equal to the force exerted by this particle on this, but in the opposite direction. Or you can say F12 is equal to actually F21 in the opposite direction, minus. Or you can write, you can say F12 is equal to minus F21, or you can say F21 is equal to minus F12. So I can rewrite this equation as M1A1 plus M2A2 is equal to F12 plus minus of F12 plus F1E plus F2E. So these two are going to get cancelled. So I'm going to have M1A1 plus M2A2 is equal to F1E plus, sorry, F1E plus F2E. Or I can again rewrite this equation as M1A1 plus M2A2 is equal to F of E, where E is the external force and F of E is equal to F1E plus F2E. Now I will multiply, this is for convenience sake, I will multiply and divide the left hand side by M. Since I'm multiplying and dividing, I am not bothered about the right hand side. So I will say M into M1A1 plus M2A2 divided by M is equal to F of E. Now I am going to rewrite this equation as M into d square x1 by dt square, right? Sorry, M1 plus M2 d square x2 by dt square divided by M is equal to F of E. Now what is this? You know velocity is equal to dx by dt. This is just a revision. And you know acceleration is dv by dt. So acceleration is d by dt of dx by dt. Or acceleration is going to be d square x by dt square. So if I'm going to deal with the first particle, then A1 will be equal to d square x1 by dt square and A2 is equal to d square x2 by dt square. That is what I have written here. Or you can say M d square by dt square M1 x1 plus M2 x2 divided by M is equal to F of E. Right? So what is this? M into is equal to M into d square by dt square M1 x1 plus M2 x2 is equal to F of E. Okay. M1 being a constant, I think the differentiation will not affect M1. So, okay. So you can write d square by dt square is M1 x1 plus M2 x2, which is equal to F of E. Or you can say M x by M into x, okay. You can say M into x is equal to F of E. So you can say M into d square by dt square of x is equal to F of E, where you can say this x is equal to M1 x1 plus M2 x2 divided by M. Now what is this M? This M is the total mass and M is equal to M1 plus M2. So you can rewrite your x as M1 x1 plus M2 x2 divided by M1 plus M2. This is for a two-particle system. Suppose I'm going to have three particles. I will say x is equal to M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M3. So I can have n number of particles like this, where I can say x is equal to sigma mi xi divided by sigma mi. If I have if I have the masses as equal to masses equal to each other, I can always say, let us take only a two-particle system. Then I will have, I'll say x1 plus x2 divided by 2 if I have the masses equal. That is, the center of mass will depend on the distance. It will also depend on the mass. I'm just going to give you a small example for that. Right? Now let me consider this scale I have on my hand. When I have the scale in my hand, I'm just taking two erasers, which obviously have the same mass. So I'm putting one eraser here and I'm putting the other eraser here. So I have a case where the two masses are equal and the two distances are also equal and the scale is balanced, right? I have a case where the two masses are equal and the two distances are equal and the scale is balanced. So now let me start pushing this mass towards the center. So what is happening? See, the scale is getting imbalanced because the distances are not now equal. So what should I do to balance? Now I take another mass and put it here so that they will balance and they will stand straight. I'm sorry, they just fell down. So if I'm going to shift it here, you can try it with another mass also. If I'm going to shift it to the center, I'm going to put an extra mass for balance, without which they are going to slide down. This is the concept of M1x1 and M2x2. So what should you be doing for a continuous mass? When I say continuous mass, when you take the scale, you cannot actually differentiate where each mass is. So in that case, your x will no more be this summation. Your x will be integral of x dm divided by dm. Why do I say dm here? Dm is the tiny mass which I'm going to consider with respect to the distance. So if it is going to be a continuous mass, then you will have to introduce a integral sign. So center of mass of a continuous body we'll see in the next lecture.